Ramesh Sivanpillai, who is going to be our speaker today. He has training in environmental sciences and physics from India, and then came to the United States for a PhD in forestry.
One more master
and master's degree, yeah.
in Wisconsin, and then A&M.
Yeah, and so he has been a very important part of GIS and T even before the GIS and T programs existed here at the University of Wyoming. Some of you all might be here because of him. He is an amazing recruiter of students and developer of new, as he says, image analysts, training image analysts. He's done quite a bit of work with disaster response and using satellite imagery, particularly with floods and hurricanes, I think I'm right, and he's going to tell us about that today. So rapid flood mapping with satellite images and training the next generation of Wyoming. So Ramesh, take it away.
Thank you all, especially on a nice day. I know we don't get a lot in Laramie, for taking the time to come and listen to me talk about mapping floods, and also, most importantly, training the next generation of UWIO students. I hope folks online can hear me.
In the middle.
Oh.
Yeah, well, there we go.
So this is a general outline I want to follow for the talk. So I will talk about what is this concept of newly flooded or inundated areas, and how we can use a technique called image differencing to pull out those newly inundated areas. But most importantly, I want to spend some time training the next generation of the image analysts. That's the reason why most of us are here. I'm not working for a state government agency or private company, because we want to train the next generation, and then how these activities enhance the student learning outcomes in the classes, whether it's all synchronous online or asynchronous or in person. I've tried these in all the three settings, and I will end it with, where are we going next? Okay. So when we think about flood mapping, it's one of the oldest tools when it comes to remote sensing, and very old application. So you might be wondering, so what is new in it to do this? So there are so many different flood maps, and they are produced in many different ways. So the first one is maps that are made during the event. So the waters are still there, and emergency response agencies are asking for, where should we send people? Where do we coordinate the rescue efforts? So we make several maps during an event, because in many cases, the flooding will change on a day-by-day basis. So what was new yesterday will be old by today. And then there are some maps or products that are made based on prediction models. So a few weeks ago, we had a speaker here who talked about these prediction models, where they have the stream network, digital elevation model. With all that, they can predict. So if there's going to be 5 inches of rainfall or 10 centimeters of rainfall, they can use that information to fill that model and come up with where are the possible areas that can be flooded. And now people are taking advantage of the feeds coming from social media to map floods. People are telling, I'm standing or my house is under flood. So they harvest all that information to make flood maps. And finally, after the event is done, they take all that information to make a cumulative map. So this is mostly used for insurance purposes or future planning, so that this map shows one cumulative area, where the flooding happened and how severe they are. So there are a lot more types of flood maps. I just wanted to highlight the important ones. My research focuses on the very first one. Okay, so I want to make it clear that I'm not mapping any of the other three things that I listed here. So our goal is, how do we make these maps during the event, and then we can give it to first responders so that they can use that information for response. And those are a few other things that I work on. So how did I get interested in this? Way back in 2011, I managed this, I have to remember the name correctly, flooding in the Midwestern US. That was the name given by the International Charter on Disasters. So they asked us to, just few days, Ramesh, you need to come and manage this. But it actually ran for 5.5 months because it started way up in Illinois and worked its way through. And they said, oh yeah, just one more state. But we went all the way up to Louisiana. So during that experience, I interacted with so many state government agencies, federal management agencies, they were all producing maps. So that's when we got this information, idea that most of the maps we got showed lot of water. And then the first responders were saying, yeah, this is good, but it's quite not what we wanted, okay? So that's where I started asking them, what exactly do you need? All the way from Illinois to Louisiana, they wanted newly inundated areas. So the goals are, we want to make these maps in a matter of hours, not like days, So all the things you can think of, what it takes for us to do a project, we need to condense everything within few hours. And the goal is to use remotely sensed images contributed to the charter. There are 17 space agencies around the world, and there are 270 satellites from which they collect data for any given disaster. And how quickly can we provide this information to the disaster management agencies? So I'm going to use different terms because I think every continent has a different name. So we call them first responders. There is emergency management people. They have so many different ways. So I might be using those names interchangeably so that they can identify where to allocate the resources and for that day. Sometimes it can change even within a day. So the first thing folks might think about, if you are familiar with remote sensing, why not use radar data? Because they can penetrate through the clouds. We will be able to see, no problem, whether you have clouds or any problem. Why can't we use radar? The simple answer is that we have very few radar satellites or satellites that carry radar sensors. And over my association with so many disaster activations, we found out that it's always in the wrong place. Okay, you want it over Canada, but they say, oh, it's over Europe. It'll take a few days for it to come back. Okay, but it has changed now with the European Sentinel-1, and they are going to launch the next one as well. So hopefully that situation will improve. But also we want to keep in mind that whenever we put out a call, we don't get a lot of people who volunteer to process radar imagery. They say, yeah, I've heard about it, but I've not worked with it. So that's one of the practical challenges even though radar can penetrate clouds and give us an accurate picture, there are fewer sensors, and number two, fewer people who are volunteering their time to make these maps. So these optical images are what we call as multispectral images. We were surprised how many of them were cloud-free. So here I'm just showing you 3 examples, 2 from US and 1 in the middle from Australia. And I just put the inserts are all from the pre-flood imagery. You can see the difference between pre-flood and post-flood. And we found there were so many images that we could use to generate these maps. In fact, so here is an example. This is from the Midwest, US, taken in 2019. You could see all the areas that are flooded. So if you could see, there is the interstate that goes by, and then there are several small cities or towns, whatever you call them. They are all underwater in this image. So the common practice is that they take that image, use some classification algorithm, whether it's statistical, machine learning, whatever you want to use, and they produce a map like this one. So in 2011, this is how we used to get these flood maps. They will send us, oh, here is the one. But though it looks correct, there is a small problem with this one. Okay. And the problem is, before I go there, so these are some examples we are getting. So this is from 2021 for Morocco. You could see everything that's highlighted in red. It's all flooded areas. So this is what goes to that country's emergency management agency. And here is another one for Nigeria. This happened last fall. And once again, you can see they put those red dots to indicate where there are settlements. So they had to do some extra work when they are identifying the flooded areas, but they are also adding those red dots to alert people, here are the places where you need to focus, which requires additional time. And not all countries have such good GIS database. So the question is, we do have pre-existing water bodies in that area. So I just pulled one where it's not a lot, but especially in southern Alabama, Louisiana, wherever we end up mapping, there are tons of water bodies that already exist. So you can compare the two. Here is the pre-flood image taken in 2017, and here is the post-flood image. So if I make a map, I'm just including the pre-existing water bodies, which I'm showing in dark blue color, with the newly inundated areas that are light blue in color. And what the management agencies want are those pixels that are highlighted in light blue. So last week I was in Louisiana. We were doing all the training there. That's what the emergency management people want to know. They say that most of the time for rescue efforts, you get people from other states or even other counties. So they are not familiar with what is happening in your area or what exists before. So if you give them a map that combines all the pre-existing water body with the new one, that's why in 2011, they were telling us, yeah, it's good, but not really good, because we were showing way too many areas under flooded case. So once again, if we look back at those images we got for Morocco or Nigeria, clearly you can see rivers and other pre-existing water bodies. They are all highlighted as flooded areas, which is technically not correct because they were underwater before the event happened. So how do we make a map where kind of erase all the existing water bodies and just show only the newly inundated areas? So that way, emergency management agencies can figure out, yep, there's an interstate. They know how many houses were there before, so they can focus their efforts on specific areas rather than having to deal with lakes, ponds, and so on. So there are quite a few ways like how we can achieve this. One is you can compare it to an existing land cover map. That's what NASA does. They make a map with the satellite image, and then they look at a land cover map. From that, they know, oh, there is a lake here, there is a pond here. They combine the two and eliminate existing water bodies. The second method is to classify both of them, a pre-flood and the post-flood, so that way you can subtract one from the other. Then there are some very complex methods, like where they use digital elevation models to say, oh, most likely, these are the very low areas. So most likely they were already underwater, so they use some techniques to subtract them. But the problem is countries like, I should not say that way, for countries like US, UK, Australia, we have more recent and current land cover maps. But for many countries around the world, those land cover maps are so outdated. So we can't use them to say, yep, it's not at all. A lot of things have changed. So you might think, oh, there was water there, but probably people have moved in, encroached that water body. Now they've built houses. So it's very risky to do it that. And then digital elevation model is another problem that we can't access that everywhere. And then it takes a lot of time to do all these processing. So after my 2011 experience, I was teaching this in my class. In ERDAS, there is a very simple tool called image differencing tool. So I always wondered, what can we do with that differencing tool rather than taking the entire image? What I have done here is converted it to an index that highlights water. So this is the pre-flood, and here is the post-flood. So all the areas that went underwater are now highlighted in bright white colors or bright gray colors. So can we use the image differencing technique to look at these two images so that I can pull out those newly inundated areas? So here is the logic behind the work. So in the post-flood image, I indicated the possibilities in white, whereas in the pre-flood image, I'm putting it in golden color. Suppose, let's say, in the post-flood image, a pixel can be water, whereas in the pre-flood, it could be land, or water and water, land and land. It means they didn't change. And over here, it's the opposite change, where in the post-flood, it's land, whereas in the pre-flood, it's water. So if I subtract the value of those two indices, for this first case where it used to be land, now it's underwater, that index is going to increase. And that's why those areas appear white in color. So this can change between 0 and 100% increase. So if I keep the gate very low or threshold very low, that means I'm going to let all the pixels in. But if I put it at 100, very rarely any pixel will get in. If I want to pull that to say, show me where there are newly inundated areas. So the way they did this is to do it by trial and error, but there is a systematic process to this madness. We just don't randomly go. And the goal is to find a number. We are calling it as optimal threshold value that will just pull all the newly inundated areas. So here are the results. So I will not go into a lot of detail. So we're using one of the indices, and you could see the threshold value. For example, in this one, with the 40% threshold value, we were able to leave out the river and many other existing water bodies and just pull only the newly inundated areas. And you could see their accuracy values next to it, So this technique works very fairly good. So the good news is I did this long time ago. This is everything before pandemics. Looks like a generation ago. So these were done with the students who are listed as co-authors here. So it took them anywhere between 20 to 40 minutes to make this map. So we were very pleased and wrote it up. And we got submitted, and this is like, I don't want to say it went viral, but it's really good to see the citations within 2 years and the number of requests we got, including the one from University of Maryland. They have the big global land cover mapping facility. They wanted to implement this. They make a lot of global scale maps, so they got this one. But with any publication, reviewers are always not happy. They said, yeah, you showed 5 sites, but that's not sufficient, because flooding can happen in many different ways. You just showed this on 5. Will it work on others? So after pandemic, I got more students, and they said, yeah, let's get more sites, less flooded, densely flooded, somewhere in between, turbid water, clear water, all kinds of combinations. Again, these kids were able to repeat it within 25 to 40 minutes. These are completely new students. They were not the ones from before. So this February, I presented it in the ASPRS conference, and we just submitted the proceedings paper. Okay. So I'm continuing this because again, this is in fall 2019. The goal was, can we cut this time even further? What techniques we could use? Because we are still doing it in US, where we have good internet connectivity and bandwidth, so we can download data fairly quickly compared to if you want to do in some countries. And even sometimes in the US, when power systems are knocked out during a disaster, how can we speed things up? And that was done entirely online. I've never met those students except when I saw Maddie when she came for the flight school. That was the first time. I have no idea how the other students, I've never met them in person. And then last fall, I was able to recruit some more students to look at analyst bias in determining where are the flooded areas. So last fall, I was teaching that intro to remote sensing class as totally asynchronous online. There was a student from Nigeria, and he said, I'm looking for a project that is a little bit more challenging. So I told them, I showed that map to everyone before the flooding had happened in Nigeria. So he is working with me. So he made 3 maps showing 3 different stages of flood, immediately after the flood, a month later, and then 2 months later, because it took a long time for the water to drain. So currently, Ben and Adeyemi are working with me We completed the accuracy assessment, and our plan is to take it to another publication. So this spring, once again, I can't say I did meet them. They're all in Laramie. This is an online class. So these students are working with, so all the work we did before, we came up with a threshold value, right? It was done by one person. So the question was, what if more than one people do the work? Are they going to come back with same answer or very close answer, or how far apart they are going to be? So those 4 students are working with imagery from 4 different sites. So every site will be worked by 3 students, and then we can see how close or far their answers are. So to conclude this part, I just want to say this newly, mapping this with image differencing technique seems to work fairly well. I could say the most 1 hour to generate a map, which is critical for disaster response. And some of the ideas I'm planning to do is take it to QGIS, because ERDAS is not available everywhere. Especially in developing countries, it's a very expensive software. So we want to try this on open source software and also the cloud-based platforms with Google Earth Engine. And all the imagery or work I showed you were done mostly with Landsat satellites. We just included Sentinel-2 from Europe, but our plan is to include more and more data. But the problem is these agencies are providing them only for that use. We can't use it for research. So we have to request them to provide sample data that we can use for our own research. Okay. So here is the big picture that I'm really proud of, So these are the students who did go through the from 2018 fall, and those that are highlighted, whose names are highlighted, are grad students. Rest of them are all undergrads. So this is the part. If I have to highlight the big thing from my presentation, today's presentation will be this slide, is to see how many went through. So how did I do this in my class? So these projects are all based on active learning methods. I'm sure by the time you hit the 8th or 9th week of a semester, you can clearly distinguish students who are really eager, ready to take more challenges, than those who just say, yep, give me the instructions, I will follow them. So this is a great way to challenge those students who are motivated, interested, and say, hey, here is a problem, would you like to work on? So thanks to my mentors in ECTL and the Science Initiative program, who helped me how to implement these things in the classes, I was able to borrow concepts from project-based learning, problem-based learning, inquiry-based learning. I stole bits and pieces from all those learning methods to come up with this design. So the key thing is you have to give them an authentic problem. In my days as student, we all did map a lake outside Atlanta, Georgia, because that's where ERDAS is located. We all got the sample CD data, and everybody in the class, batch after batch, will do the same thing. Or some rainforest in Amazon, which was good. But these things are forcing students to kind of move away from tests. They are not asking me, are you going to ask me this question? Or should I know the wavelength of the band in order to calculate? Those are important, but in a traditional class, the focus sits on memorizing those things and you take the test or exam, and then 6 months later, they ask, what do you mean by NDVI? Yeah, you told me something like that last fall. So that's why these projects provide great opportunities. So you give them the data set and you ask them to explore. They come back and they say, Ramesh, is this what you taught me in class third week or fourth week? Should I use that? Say, yes, that's what exactly I was hoping. But in a traditional class, it's very difficult to make students to go back and look. So when something goes wrong and they say, hey, you told me this image is cloud free, but I do find some clouds here and there. What do I do? Oh, please go back. We talked about this earlier in the semester. So this gives the student an opportunity to recall what they learned. And if they are not clear, they can go back and review what they missed before. So in any remote sensing application, Austin can vouch for me, make a success of a project depends on selecting the appropriate images, okay? So this project has given so many opportunities for students to learn. So you may recall the way we are identifying newly inundated areas is based on a pre-flood image. So it'll be like music to my ears when students will come and say, Ramesh, what if I had taken a pre-flood image, which was also from another flood year? So that means you are going to underestimate. Or what if you have selected a pre-flood image from a very drought year? Now you are going to show. So that shows us the importance of selecting an appropriate pre-flood image. Now, why is this important? If you look at remote sensing literature, it's changing now. The last thing I listed here, so many studies will report decadal change. This is how the landscape changed from 2000 to 2010 to 2020. But they don't really pay attention to was one of those years, a drought year, wet year, normal year. They don't place importance to that one because that decadal change sounds more attractive, right? But these projects have helped not all, most of the students to focus on what's the trade-off of selecting the images. And sometimes we go for the closest season between the pre-flood and post-flood. I didn't emphasize that part. One of the indices did not produce a good product. So it turns out in the Colorado, where we were mapping, in the pre-flood image, the crops were harvested. And in the post-flood image, the crops were still there. So that difference messed up the index and it confused our algorithm or the logic. And they said, oh, under these circumstances, I should not use this index, whereas the second index was not sensitive to that land cover change. And this is a great discussion, because when we talk about water, especially during flooding, it comes in all colors, right? There is turbid water. Some places it just looks like dirt, brown in color. Some places it's all over the place, right? Water. And these indices are sensitive. So then they will say, Ramesh, how come this index is picking it up, whereas the other one is not? Oh, can you go back to the module on water? We talked about how water interacts with electromagnetic radiation, and especially if you have floating vegetation or debris or anything in it, how does it shift that reflection pattern? Oh, okay, now it all makes sense. That's what they say. So it's really, really good to see. And then some of these indices that, or some of the images, the flooding was very shallow, and we could clearly see the difference between the two indices, how they picked up where it thought it met that threshold or not. So once again, students were able to understand things better. And most importantly, we try to stress this in our classes. You can never make a map that is 100% accurate, okay? Any map is going to have a trade-off, but here is a real-time opportunity for them to test it out. Yes, you can spend hours making a perfect map or try to get it as accurate as possible, but there are people who need this information several hours ago. So where do you draw the line between how accurate you want to get or how much time you need to make that product? So they are always interested. What if we overpredict? What's the consequence if you give a map to a first responder with slight overprediction? What's going to happen? Or if you underpredict, what are the consequences? Oh yeah, they will leave out some of the flooded areas. That's exactly. So these are some concepts I try to teach in my remote sensing class with user accuracy, producer accuracy, omission, commission error. Now, it didn't resonate really well, but once they had the product, you could see students come back and say, oh, now I know what you talked about, commission error and omission error. See, thank you. That's what we are. And then this whole idea of uncertainty in map products, that you cannot get away from that one. So in general, if I have to sum this up, these projects have helped me to convert my classroom as a learning environment where information is not flowing from the instructor. I'm not standing at a podium and opening everybody's brain and filling with information. But this one, we are creating an environment where we all learn together. Because I'm sure as instructors, it's a common question, right? Students come in, is this what you want? Is this what you expect from me for the answer to this question? And I don't know, because I've never been to Arkansas or I've never been to these states. So we will figure it out. So this way, it's a great environment for learning. And the only, regret I have is I can't make the entire class to do this, that's the only thing. So there are some challenges. I don't want to say that everything is all great. So it's a single project that I break it into small components, and then I assign it to 3 or 4 students. So that means I'm taking a risk. So if one of them fails to deliver the product, there goes the entire work, So selecting students who are really interested to do this is vital. And always, I'm sure everybody can tell there are, faculty members who have taught in this university much longer than what I have done. There are students who are overcommitted. They will say yes to everything. And so that's the one you need to keep an eye for. So sometimes you don't want to recruit the best student, but if they want to do it, absolutely okay. But sometimes you will see students who kind of understand what I'm talking in class, but they are not good in taking tests, but they really want to learn this. So those kids are absolutely suited to do these type of projects, along with those bright and best. So I have over the years, I've identified many metrics that every time I teach, I have my radar on, and then I can see, okay, who is here, who wants to do this. So I do a pre-assessment in my classes. So that will give me a good indication of who really wants to do these type of things. And the other challenge I have is because most of these are undergrad students, I want them to write the first draft of the manuscript, but they say, no, we don't have time because they work with me for 1 or at most 2 semesters. So they are happy to write what they did and they give it to me along with the results. And it's my job to put all of that together, which takes a little bit more time. But hopefully I'll be able to do things more. So, but bulk of my students come from College of Ag. So I use the same concept to do crop mapping. So these are all students who have called their parents, uncles, aunts, whoever they worked with to find out what happened in the crop field. And I give them the imagery, but these ones have a lot more success because it's 1 student per project, So they have any questions, they call their parents and say, hey, what did you do to the field? So that's how all those videos are online through UW and also through College of Ag and Natural Resources, so you can watch them. So I want to end this with the international charter is the motivation behind my research in disaster response. So there are 17 space agencies from 270 countries. But I'm sure you have watched the news recently, both the frequency and intensity of these hurricanes, tornadoes are increasing. So if you talk to the responders, they will be very happy to take any updated information you will give, but these newly inundated areas are really helping. So hopefully I will be able to train more students in my classes, both formal courses and also through independent studies, because we need more people to do this work. So here are some of the things where I was able to get UW's name in the international charter. So my first one was Central Midwest flooding. Then I did the California wildfire in 2018. And then this is the most recent one, the Dominican Republic, Where do I want to go? So if you go to the USGS disaster data distribution site, and if you do the search for the 2021 Hurricane Ida, you will see WyGISC listed as one of the data providers, because right in the middle of the pandemic, so I thought, okay, got some time. So I made my own map and we were able to get WyGISC logo, everything named into the USGS system. And my goal is to have my students do this. And that way we can showcase, once there is a disaster. So it's not just, Ramesh gave me a bunch of lab instructions and he taught me several lectures, but this really translates to something that people can use on the ground. So with that, thank you so much for your time. And it's important that I acknowledge all my funding agencies, AmericaView, which is funded by USGS, and Shana, the director of the Wyoming NASA Space Grant Consortium. She funded part of this research. And then, of course, the international charter. So with that, I will stop and take any questions that you might have. Thank you.
Anybody needs to move on to we can ask some questions in the meantime.
So it's 12:54. Yep. If you have any questions in the chat? Okay. Yes.
What other purposes could this be used for besides like disaster management?
So this group is mostly focused on disaster. So we do wildfires, landslides, mudslides, earthquakes. So there are tons of images for the Turkey-Syria earthquake because the 270 satellites become very useful because none of the roads exist, right? The roads are gone, or even if they are, there are debris everywhere. So these images provide very valuable information. But then otherwise, for non-disaster applications, people are interested in looking at deforestation or why, things that are, I think these folks who are doing those are very clever because they do have international monitoring programs that will be able to identify where deforestation is going on. So these folks are very clever now. So they don't cut a large area. They cut one tree here, one tree there, so they can escape any of the monitoring tools. But folks are coming up with sub-pixel detection to see whether something has changed within a pixel to see what's going on. And of course, urban growth. If Jeff was here, he would have given a complete picture of how we use not these, but the different types of imagery to see how cities have grown. And there are some great videos because this is the 50th anniversary of the Landsat program. There is a great video that shows how Las Vegas grew over time as the city was growing, how Lake Mead's surface area declined, So you can see two things in the same image as it goes through. Okay. Any other questions? Okay.
So how can some of this be incorporated into, getting the VS? Hopefully we can have a lot more students. We're thinking about student club groups maybe, and projects that they could do. Some engineers have, competitions for design or something like that. Is there something that this could lead to for a student?
Yes, there are some. Actually, many ideas. I didn't present everything that I've done. So one thing that happened 2021 fall, there was on top of everything, a tornado went through Louisiana, certain parts of Louisiana. So we had 0.5 meter aerial imagery from NOAA. So I was able to get those images to some students. All they did was open Google Earth for pre-event and open this one for post. And they just placed points everywhere. And we were just sending it back to Louisiana, Yes, OpenStreetMap is another idea, like where people are going. And there are many ways in which we can engage students. Austin, any question?
There's a famous global surface water product to get off there, but they provide pixel values of surface water and almost at the monthly and yearly scale for the last 20 years. I wonder if you could take advantage of that for your free stuff.
Definitely, we are looking into it because sometimes we could never get like a cloud-free image on a single date. So one thing Google Earth Engine does is it creates a composite. So I'm looking at that one for a pre-flood image, and yes, USGS is also slowly shifting to delivering products rather than imagery. So those are two things. Yeah, thank you. I will definitely look into that. So if you know any students who are still looking for a class this fall, please recommend my course. So you get to see what they can do, So it's not all the labs that Ramesh made, and everybody is doing the same thing. Okay? So some of them will be doing flood mapping, some will be working with their parents or relatives, crop fields, a few will be working on wildfires. So it's all over the place. Yeah. Any online questions? Okay. No, thank you so much. Yeah, once again, it's a very nice day and thank you so much for coming. Yeah.
Thanks for looking at this.
No. Yeah.